Okay, this is the second part. Now we're going to talk about the goodness of fit test. This is the chi-square test where we have one categorical variable. If we have one categorical variable with several categories, then our question is there goodness of fit between what we see, the percent we see in the categories of this categorical variable, and the percent we hypothesized we would see? So it's used in a case like Reese's Pieces, the color of Reese's Pieces. I was looking online today and someone hypothesized that 50% of Reese's Pieces are orange, 25% are yellow, and 25% are brown. So our null hypothesis spells out the percent that we would expect to see in each category. So in that case, our null hypothesis would be the percent that are orange is 50%, the percent are brown 25%, and the percent that are yellow is 25%. The alternate is that that's not so. The percents are something different than that. So the null is there's nothing going on. If we looked at all Reese's Pieces, the population of Reese's Pieces, we would find that 50% are orange, 25% are the other two colors. The alternate we don't specify, we just say, nope, the percents are something other than that. We collect a sample. The chi-square compares the observed count of orange, brown, and yellow to the count we would have expected to see if, in fact, 50% were orange and 25% were each other color, and would come up with a p-value, and then based on that p-value, we would decide to accept or reject that null hypothesis. Or with genetics, fruit flies, that if the parent fruit flies have some sort of genetic whatever, obviously I'm not a geneticist, then we would expect a certain number of the offspring to have curly wings or striped bodies or whatever it is that fruit flies have. So we would hypothesize that we would see a percent in each category, and then we would let these fruit flies do what fruit flies do and see what their offspring looked like to see if there was goodness of fit between the percent of each kind of fruit fly that we saw and the percent that we hypothesized we would see if the parents had a certain genetic profile. So the example we're going to look at here is from Michigan. As of April 9, here was the distribution of deaths from COVID-19 in Michigan by race. There were 334, 430 Black, 11 Latino, and 66 Asian deaths. So actually there were 1,076 deaths from COVID-19, but of those, only 841 had the race recorded. So obviously it's a categorical variable. We have white, Black, Latino, and Asian with 4 categories. This is actually other, but they said most of these were Asian, so I just wrote Asian. So we have one categorical variable with 4 categories, and we have the observed count of deaths for each race. What we want to know, is there goodness of fit? Is there goodness of fit between the percent of deaths that go with each race and the percent in the population of that race? So do deaths reflect population or something else going on? So we have one categorical variable. We wonder about goodness of fit. So our null hypothesis is that, yes, these deaths exactly reflect what's going on in the population. There is nothing going on, but the percents match. Well, the known percent in the population for each race is that 78% of Michiganders are white, 14% Black, 5% Latino, and 3% Asian. So our null hypothesis is the percent of deaths that belong to white people are 78%, and you can either write 78% or 0.78. The percent of deaths of that are African American is 14%. The percent of deaths that are Latino is 5%, and the percent of deaths that are Asian is 3%. So we have goodness of fit. The percent of deaths from each race exactly matches the percent of that race in the population. The alternate is that is not so. The percents are something other than that. So now it's time for a chi-square test. So we need our observed counts and we need our expected counts. We have our observed counts. The question is, how many would we have expected to see among 841 people if the percent of deaths in each race reflected the percent in the population. So if 78% of deaths were white people, then 78% of the 841 would be white. We would have expected to see about 656 white deaths among 841 people. 14% of 841 is 118 people. 5% of 841 is about 42. 3% of 841 is about 25. So here's the number of deaths we would have expected out of the 841 to go with each race if deaths reflected the percent in the population, if there was goodness of fit. So I had the computer compute the chi-square statistic for us. So we didn't spend a year and a half calculating it, and it was huge. It was huge. It was 1,075. Degrees of freedom are the number of groups minus 1. We have 4 races, so we have 3 degrees of freedom. And if we went to table X in the back of your book, but we would find this. But the p-value was teeny tiny according to StatCrunch. So no matter what alpha you want to pick, that p-value is going to be less than or equal to alpha. So we reject the null hypothesis that there is goodness of fit, and we believe that the percent of deaths does not reflect, for each race, does not reflect the percent of that race in the population. So then the question is, where do things go wrong? Where do things go wrong? And there are a couple ways you can check that out. But the easiest is probably just to compare the expected deaths to the observed deaths. So we only saw 344 white deaths. And when I say only, I don't mean only. Each one of those people came from a family and was loved by someone. So that we saw 334 white deaths. We would have expected way more than that if there was goodness of fit. But here's where things really go wrong. We expected only 118 African American deaths, and we saw 430. 430. So there are way, way more black deaths than we would have predicted or expected if the percent of deaths in each race was reflected the percent in the population. For Latinos, there were fewer than expected. We expected 42, we saw 11. And for Asians, there were more than expected. We expected 25 and saw 66. Okay, but the big glaring difference right here, of course, is this one. And this one. And this, of course, has caught the eye of the governor and people on the national level. And hopefully this will lead to improvements in various ways so that this doesn't continue. So goodness of fit test. We have one categorical data variable with multiple categories, and we want to see if there's goodness of fit. Does the percent in each category match some preconceived idea? So our null hypothesis is yes, it does. There's nothing going on. The percent in each category matches what we hypothesized, what we expected, or what we thought we might see. The alternate is nope, the percents are something other than that. The computer comes up with a chi-square statistic and a p-value, and then we make a decision. Is there goodness of fit between what we see in our sample and what we hypothesized or not?